Do a quick double check. Notice that y is going to be the smallest side length, and 4 is kind of the realm that we're in. So we know we need to be less than 4. So if we had anything larger than 4, then we would know that we messed up because the hypotenuse needs to be the largest side. And 1.37 seems about right because it's within the world of 4. Okay, so now we're going to solve for the adjacent side length. So we want to solve for the adjacent. Always reference back to the thing that you're given. On the off chance that you accidentally calculated for your opposite side incorrectly, don't use it to solve for the next piece if you can just do something that you know is correct. So always go back to what's been given to you if there's ever like a multiple step problem. So here we have adjacent, we want adjacent, and we have hypotenuse. So we go to SOHCAHTOA and we find where adjacent and hypotenuse are together, and that's with cosine. So I'm going to do cosine of 20 equals the adjacent side length over the hypotenuse. Again, you can put this over 1 or realize you multiply both sides by 4, and we get that x is equal to 4 times cosine of 20. 4 cosine of 20, and we get 3.76. Again, doing a quick check, it's less than 4, which is good, and it's greater than y, which we know it should be. The reason why we know is not because the picture looks like it should be, although the picture was drawn in a way that makes sense. It's because we know that 20 is going to be the smallest angle here. If we subtract 20 from 90, we get 70 for up here. And the side lengths are directly affected by its opposite angle. The smaller your angle is, the smaller the opposite side length is going to be. So if you keep on making it larger and larger and larger, your opposite side length is going to get bigger. And so the smallest angle will have the smallest opposite side length of all of the side lengths. Okay, I would like for you to do this guy on your own. Remember to label your relationships. What do you have? What do you need? And figure out where in SOHCAHTOA can you get that information. So I'm first going to label my side lengths. 15, like a spotlight, opens up to 2. So that's going to be my opposite side length. And y is across from the 90, so that's my hypotenuse. So I've got O and H, and I know that that's sine. Sine of 15 equals opposite over hypotenuse. So it's going to be 2 over y. This guy can get tricky because sometimes we get really confused. Again, put this guy over 1 and cross multiply. 2 times 1 is 2 equals y times sine of 15 is y sine of 15. Now, to get y by itself, we need to divide both sides by sine of 15. So y equals 2 over sine of 15. I just put y on this side because I wanted to, but realize what I did is I divided both sides by sine of 15. So it'd be 2 over sine of 15 equals y, which I then just flipped it because I like the way it looks this way. When you plug it into your calculator, you get y equals 7.73. Okay. The next reason why we use SOHCAHTOA is when we're trying to solve for angles. So if we want to solve for an angle in a right triangle, we're given side lengths and we need to solve for this guy. We're still going to set it up the exact same way. So we're going to start by labeling our side lengths. This guy is the hypotenuse. This is the opposite. This is where the spotlight is coming out, which means our square root of 2 is our adjacent side length. So if we have adjacent and hypotenuse, that means we're dealing with cosine. So I'm going to write cosine of theta equals the square root of 2, my adjacent side length, divided by the hypotenuse, which is 3. Once you set up this relationship, the thing is that we want to get theta out of cosine, and cosine is not being multiplied by theta here, so do not say division. What we need to do is we need to get it out of this machine. And the only way to get theta outside of this machine that is cosine is by taking the inverse of this situation. Because if you remember, the inverse of any function undoes the previous function. Anything with inverses is where you flip your input and your output. And so when you're flipping your input and your output, that means that what goes inside of cosine is the square root of 2 over 3. And what goes outside now is theta. So all we've done is flipped these guys. Now, this guy is no longer called cosine. It is the inverse of cosine. And we denote that, we denote that by doing to the -1. That means inverse. I know it also technically means with your exponent laws to do 1 over something, and it's really confusing, but that is not what that means in this case. If you ever see a function like that raised to the -1, that means it's the inverse of that function. Whereas if you had like x to the -1 equals 1 over x, f of x, where the f is raised to the -1, just means the inverse of f of x. So cosine to the -1 of x is the inverse of cosine of x. Okay, so these are two different things, although they look the same. There is a place in your calculator for this cosine to the -1. If you go into your trig values, it's just below cosine. If you have a TI-84, it's just above it, which means you need to press the yellow button, the second bucket button, and then press cosine in order to get that yellow text up top or whatever color it happens to be on your TI-84. That means you just need to press that color button and then that button. So for instance, there's blue text above our buttons here. I need to press the blue button in order to get that function of that button. Okay, so I'm doing the inverse cosine of the square root of 2 and then divide by 3. And it gives me 61.87. It does tell me correct to the nearest degree up above here, which means I need to round to the nearest whole number. So theta equals, and that's going to be 62 degrees. All right, we will do the next one together, and then the last one you're going to do on your own. All right, so we've got theta right here. Opposite of it is going to be this guy. And we have the hypotenuse. So we've got opposite and hypotenuse, which means we are using, you can write SOHCAHTOA at the top of every single problem. Write it at the top of every single problem, and then say OH, OH, we're using sine. Sine of theta is equal to opposite over hypotenuse. The only way to get theta outside of sine is we have to do the inverse, the only way. That means I'm going to do sine to the -1 of 12 over 13 equals theta. Go to your calculator, trig, sine to the -1, 12 divided by 13. And we get that theta is equal to 67 degrees. Okay, do this last one on your own and then we'll go over it. First thing I do is I should always label my side lengths and the relationships with the angle. So I know that this guy right here, 8, is opposite, and square root of 7 is adjacent. We are not using the hypotenuse at all. So the only one that doesn't use the hypotenuse is tangent. Writing out my relationship first, tangent of theta equals opposite over adjacent, 8 over the square root of 7. You do not need to rationalize the denominator before you do anything here. You don't need to rationalize, you technically don't need to rationalize the denominator at all, ever. It's not like it doesn't work if you don't rationalize the denominator. Mathematicians just really like having one answer for things, in case you haven't noticed. So mathematicians really like to have one answer for things. And if you don't rationalize the denominator and simplify, then there's technically an infinite amount of answers that you could give into any problem. And so they just want to streamline it. And so that's how they chose to streamline it, is that you have to rationalize the denominator. But it doesn't matter in this case because we're not getting a final answer. What we want to do is just get theta by itself. And the only way we can get theta by itself is we have to take the inverse of that function. So tangent to the -1 of 8 over the square root of 7 equals theta. The only thing taking the inverse does is flipping your input and your output. That's it. Go ahead and go over to your calculator. Trig, inverse tan 8 divided by square root of 7. Boom. And the answer we get is different than the answer I got in my answer key, but that is okay because I'm pretty sure that this is correct, that theta is equal to 71.7, which means we're talking about 72 degrees. All right. Great job, and we will practice this in class together.